All right, eighth grade. We're starting session 3 of lesson 19. That's on page 459, 459. Getting back to exponent stuff. This situation, we've got this Rangoli for Diwali. Diwali is a festival that the Hindus have, a holiday of theirs. And so in this situation, the original one is 15 inches long. One side is 15 inches. But Ronnie wants to make a new one that's triple as long. So imagine you make it 3 times longer. Can I zoom out? Let's zoom out like this. There we go. 3 times longer. So imagine 3 times longer. Imagine I made it a perfect square. But if it's a square, like they're saying, then if it's 3 times longer here, so will it be over here and all there. So consider that if you make one side 3 times longer, can you fit just 3 more in here? Or rather, would you only have 3 that can fit in the new one? How many do you think could fit? You want to pause, think about it? In any case, with this video, hoping that you guys take time to go through it. When you need to pause, pause. When there's a problem that I'm going to solve, take a second and pause, see if you can solve it on your own. I can give you the answers all day long, but that's not going to be useful to you at all on the exam. So the more you try to practice, the more you're willing to make mistakes, then the more you're going to end up doing well because you've practiced it. So don't worry about getting it right the first times. Just keep trying. All right, next page. Let's see here. And I tried to make the video earlier and then things crashed. So I've started writing already. So bear with me while we look through it. Like I said, this is going to be 3 times longer on one side. So in other words, one side originally is 15 inches, but then it becomes 3 times that long, 3 times 15. And remember, the area of a square is side times side. So area of a square is side times side. In other words, how could you make that with an exponent? Side squared. And if you know your properties, well, you know there's an invisible power of 1 on these s's, and you add those two to get 2. Okay, moving forward, we've got 3 times 15. That's one side. And we take another side, 3 times 15. That's for the new rug, the new Rangoli area. But the original one, to find how many times larger it is, you divide by the original. The original is 15 long times 15. So let's rearrange things. Since it's all the same operator, multiplication, we can just move things around, no problem. So we're going to move the 3's, put them together, 15's, put them together. On the bottom, we keep the 15 and the 15. In the next step, they put a 1. So I'm just putting that 1 right away. If I multiply times 1, it doesn't make it any bigger or smaller. It stays the same. So we're going to put it there just so it makes sense. So now you get 3 times 3 over 1, 15 times 15 over 15 times 15. You can separate it all like that. And this on the top is exactly the same as this on the bottom. So it ends up being 1. This same thing divided by same thing is 1. Anything times 1 is just that. So 3 times 3 is 9. 9 times 1 is just 9. And they showed other ways you might be able to think about it. Like I said, side squared. And then they just did the side squared. And that's what you end up with. What is the size of that rug, of that rangoli going to be? It's not a rug, it's a rangoli. 9 times whatever 15 times 15 is. Is that 225? You guys can check my work. I don't know if I've memorized that. In any case, let's move on. We already figured that out. It's 9 times. 9 times larger. I showed my work on the other page. If you showed your work on that page, you don't need to redo it. But if you do, it'll probably help you to remember. So it's not a bad idea. All right, modeling it. Rewrite the right side of the equation. So the left side stays the same, but the right side, we know it's the right, so I mean the right of the equal sign. 3 times 3, 15 times 15. So we've got our 3 times 15 squared equals 3 squared times 15 squared. So we got the 3 times 3, that's 3 squared, and the 15 times 15, that's 15 squared. Now they want to see if we understand what's going on here. We've got 3, and we're going to replace 3 with the letter A. We got 15, we're going to replace 15 with the letter B. And we've got 2, we're going to replace that with the letter N. We'll zoom in. All right. There we go. I'll try not to make you too dizzy, guys. I won't do that as much as I can. All right. 3 times 15 squared becomes A times B to the power of N. 3 squared, well, we replace 3 with A, so we're going to put A. And we replace 2 with N, so we're going to put N. And same happens with the 15. We replaced it with B, and again, we replaced 2 with N. So this is a new property. A times B to the power of N equals A to the power of N times B to the power of N. And vice versa. A to the power of N times B to the power of N will equal A times B to the power of N. So it can go both ways, right? All right. Now, the expression 3 times 15 squared is a power of a product. How can you write the expression 18 cubed times 35 cubed as the power of a product? All right, I kind of just said that, so think of this and see if you can figure it out. I'll give you a brief moment to pause. So hopefully you did figure it out. Hopefully you tried it. That's what I'm really curious about. So how can you write this expression as a power of a product? So we're going to take our 18 and our 35. We're going to multiply them together. And we can do that because it's cubed. And so is the other one. Let me, all right. Sorry guys, had to check on something. So we've got 18 times 35 from here, but we can only do that because the power is the same. The exponent is the same. And then we just stick that same exponent on the outside. And now you've got a power of a product. And that's it. And we followed this property here. Moving on, the side length of the original rangoli is 1.25 feet. That's 15 inches, 1.25 feet, or 5/4 of a foot. 5/4 feet. Area of the rangoli in square feet can be written as a power of a quotient. All right, we're going to look at a slightly different property. Here we have a power of a product. I'm going to write that down. Power of a product. Here you have product of two powers. So watch out. Product of two powers. If there were three of them, it would be three powers, right? All right, so back to down here. If it's a quotient, we're going to have something quite similar. But instead of multiplying, what do you think we're going to do? We're going to divide. That's right. All right, so you get 5/4 squared, which is the same thing as 5/4 times 5/4. And you can mix that up into one big fraction, 5 times 5 over 4 times 4. And to rewrite that as a quotient of two powers, well, 5 times 5 is 5 squared, and 4 times 4 is 4 squared. So let's see what we've got there. You end up with 5 squared over 4 squared. What do you think that property is going to look like? I'm going to write it down. So I'm scooting it down just because I want you to be able to compare it to what we had here. If we start with A over B to the power of n, so some number divided by some other number to the power of some other number equals A to the power of n over B to the power of n. So see, in our original thing right there, you've got some number A. If you replace 5 with A, you've got another number 4. If you replace that with B, you'd have A over B to some power. If you replace 2 with n, you've got A over B to the power of n. And they worked it out. You do all that, and you end up being able to have this. Here we'd have A times A over B times B. And that's the same thing as A to the power of n over B to the power of n. If there's only 2, you'd replace n with 2. If there were 3, if there's another times 5 there and another times 4 there, b power of 3. And you keep going like that. So here, instead of the power of a product, it's the power of a quotient. Power of a quotient. This one versus quotient of two powers. Yes? Okay, let me pause, guys. All right, so here we've got power of a quotient versus the quotient of two powers. Here we've got the power of a product versus the product of two powers. So you just got to be careful to make sure, is it the same number here? Well, yeah, we started with that one, so you can just right away do it. If it's backwards though, where they give you something like this, if the power is the same, then you can use this property. So just watch out. You gotta be paying attention to it. All right. On this one, how would we do it? 3D. We're on page 461 already, by the way. Did you get a chance to try it out? Pause if you didn't. Let's go ahead and see what to do. I'm going to leave these in view for now. I think we can handle it. We need to make it quotient of 2 powers. All right, so watch how that is, quotient of 2 powers. Is it this one or is it this one? Well, you can see it's this one. So we're going to just make that 6 go to both of those. All right, so I'm going to do 2 parts. We're just going to rewrite this 5/4. We got a quotient. And then we've got our power, 6. So we've got the power of a quotient. And that equals 5/4 times 5/4. We're going to keep doing that 6 times in all. Oops, did you catch my mistake? I think you did. I bet you did. All right. Get those dots in there. Let's fix my mistake really quick. All right. How many of you caught that? All right. 1, 2, 3, 4, 5, 6. And we've got power of 6, so that's correct there. And then we could count how many there are. There's 6 on the top, 4 on the bottom. And if we do it exactly the same way they were doing up here, where they mix it into 1, well, let's go ahead and do that. 5, 2, 3, 5. And 6 over 1, 2, 3, 4, 5, 6. So we get 5 to the power of 6 over. Ooh, I keep wanting to do that. So watch out, guys. Be very careful when you're doing these. It's easy to mix up your numbers. All right. So we've proved that we can use that property. All right. That's the idea. In a test, unless it tells you to, you can go from this straight to that. All right. I don't need to see these middle parts unless it's telling you to do that. Okay. So be paying attention to what you're supposed to be reading. All right. On the bottom here, think about all the models and strategies you've discussed today. All right. Well, I'll let that up to you. What of this all made the most sense to you? What helped you figure this out the most? I always skip this, but honestly, it is a good thing to figure out. If you know what helps you, then you can learn more easily. So you're learning how to learn by answering something like this. For me, taking it step by step really helped me. Remembering chunking, so taking it piece by piece and then putting it all together, chunking it can help me. So if I looked at here, well, I know this is a product and that's a power, so it makes sense to call it a power of a product. But I know this is a power and that's a power. So we've got the product of 2 powers. And I never really described it that way. So it kind of helps to just take it slow, take it piece by piece. Okay, let's keep moving. Apply it. All right, so let me zoom out here a little bit. You guys are kind of just going to work this out on your own. Yeah, so see what you can figure out there. I'm not really going to do it here. Well, Yeah, I'll see what you guys can figure out first and see where where you are with it. If you haven't tried anything, I'll know you didn't try it. And I'll probably do another video, or we'll see it in class, something like that. All right, so give it a shot. I expect it to be done hopefully next time we see each other. Over here, same idea. Evaluate all that. They give you an example. So try it out. Let's see. Let me explain this example here. You take -3 over 2 to the power of 4, all to the power of 2. So what is this? We've got a quotient. So it's the power of a quotient. All right. So if you're looking for power of a quotient, then you'll be able to find that you can raise both numbers to that one power. So here, you'd raise this to that power. Would we replace the 4 and the 2? So that's kind of a little different. So they even explained that to us. And it might help you to consider this. I'm going to just stick in a 1 here. Remember, if there's no power, there's an invisible 1. Let's zoom in. All right, so we've got our invisible 1. And after that, that's better. Invisible 1, but this has a power, it's 4. So remember, we can put that in, but don't forget about your older properties. And by older, I mean from the session before. Let's go, I'm going to give you a quick tip. Page 447, you've got all those properties. So page 447, we've got a power of a power. Do we have that in this situation? Well, let's take a look. Got a power of a power, or sorry, power of a power. There we go. Power of a power. And then power of a power. Because remember, the property for power of a quotient, you stick that power onto both numbers, the numerator and the denominator. And then, since there's already a power there, technically there is a power here. It's 1 and 2, and you just do 1 times 2 to get 2. Here you're going to do 4 times 2. So remember, you take those and you just multiply them. So you do 4 times 2, and you end up with 8. A reminder, if you've got a negative raised to an even power, that negative becomes a positive. So it's the same as 3 to the power of 2, or 3 times 3. That's 9. 2 to the power of 8 is 256. If you have a calculator, feel free to use it for that kind of thing. All right, but I'll be. All right, where was I? So yeah, with all these powers, be careful. You probably don't know how to do it with the calculator yet when you have all these different properties. It was a homework at the beginning to get a calculator so I could teach it, but I don't think most people have a calculator. So let me see. Let me grab one and see if I can show you. All right, guys. So this is how to do some of this stuff. Turn that off. Does it help? Nope. You won't really be able to see on the screen. I'll try to show you somehow, but these are the buttons. So let's say you had this one here. All right. You'd put the parentheses, -3 over 2. And this like half triangle arrow button thing, that's the power. Okay. And I'm not even sure if it's going to work because I haven't used this function on this kind of calculator. We'll find out. Equals. All right. Is that possible? Is that 9 over 256? Let's find out. Um, yep, there we go. But if you do that on a test for this, are you going to get any points? No. So what you'll have to do, you get all the way to this step. Well, you could keep the 9 as -3 to the power of 2, I guess. But then you plug it in. If you don't know that 3 times 3 is 9, I recommend trying to memorize more of your multiplication table. It's not too late. And then 2 to the power of 8, I don't expect you to write down 2 times 2 times 2 times 2 times 2 times 2 and then try to figure that all out. Definitely calculator, 2 to the power of 8. So remember, that's the to the power of symbol. If you want the next number to be an exponent, that's what you press. And that equals 256. If you guys don't have a calculator, what are you going to do? Are you just going to fail the test? Please don't. If you get to this, that's all I need. I don't need this part, okay? This is just extra. So this is what I would need on the test. Even this would be enough. If you got 2 power of 8 on the bottom and 3 to the power of 2. All right. You could put that it's negative, but I'd expect if you do that, I'd expect you to show me that you understand that a power of a negative, sorry, an even power of a negative means you'll end up with a positive answer, okay? So I expect that. From here, I don't need you to tell me that that's 9. I don't need you to tell me that that's 256. This is the answer that I would want. If you take it to the next step, that's fine. But I do want to see these parts. I want to see all of this going on here. All right. All right. So try it out, see what you can figure out. Yeah, some of these are straightforward. Some of these are a little trickier, like in here, where you're mixing different properties. If you aren't sure of your properties, what should you do? Well, you can write them all out. Okay, where were we, guys? All right, so yeah, see what you can do. I don't see anything that you shouldn't be able to do yourself. Um, I have some things. Oh, let me go ahead and pause again. All right, guys. Let's get things started again. So there we go. Back in focus. All right. Yeah, so there are a few things here, might be a little confusing. If you go piece by piece, like I said, do that chunking, then you should be okay. I'll give you one more hint. Don't forget, even while you're doing a new property, a new kind of thing you're learning, there's old things that still count. So if you have anything where you can do PEMDAS, then you should try that out. All right, that's my hint for now. Give these pages a try. This is page 463, 464. So try it out. We did the connect stuff. You should try to apply it, practice it, and refine it. Try to get it the best you can. We'll eventually go over things. The refine it though, it looks a lot like a quiz, doesn't it? If you're able to do the refine it, you'll probably do pretty great on the quiz. All right, and then lesson 20, we'll get to that next time. Thanks, guys.